Okay, let's see. We're starting chapter 11 today, and it's on statistics. And anyway, lesson A is on discrete data, which is just data that we can count, just so we can see, feel, touch. It deals with numbers, exact values. So, anyway, the lesson kind of starts off with, we go to the clipboard, a picture of this. Ooh, oh, there it is. Starts off with this thing right here. So I kind of want to, oops. There we go. So it deals with just the different types of ways we can organize discrete data. Keeps ending. Anyway, as where I was, these are different ways, or three of the different ways. There are other ways to display discrete data. We can use a tally table like this right here, where, for example, okay, this is for the number of nights people stayed at a particular hotel, and so as we can see, the person at the counter must have kept track and had a little column right here that said, okay, 1 night, 2 nights, 3 nights, 4 nights, 5 nights, 6 nights, 7 nights, 8 nights, and so on and so forth. And so if someone came there and stayed 2 nights, she would put a tally there. If they stayed 6 nights, she'd put a tally. If they stayed 2 nights, she'd put a tally, and so on and so forth. And at the end of her time frame that she was counting, she went ahead and she added up all the tallies, and she put that in the right-hand column right here. So as you can see, these numbers match the number of tallies. And you can also represent that same data using a column graph, where the number of nights 1 through 8 that match here go along here, and they have this frequency along the side. The highest number is 10, so that's why there's 10 up here, and you always start with 0 right here, so that's why that's 0. So that's called a column graph or a bar graph. You may have heard of a bar graph before. And then a dot plot is the same as a bar graph, but it uses dots instead of bars. So for the 6 people stayed 1 night, so you would have 1, 2, 3, 4, 5, 6 dots, and so on and so forth. This thing's a little bit sluggish today. I'm having problems with the all-share cast on this TV, so anyway, I apologize if it's not quite, what I'm doing is not matching up what I'm saying. Anyway, on for the next page. It talks about the distribution of a data set. Oh, here goes ending again. This is our next chart. I'm going to insert there, I guess, right here. It keeps ending. I'm going crazy on this thing. Okay, I might try to piece these videos together. That's a lot to piece together. This one. Okay, let's talk about the distribution of a data set. The picture didn't turn out great, but anyway. Okay, so we talked about the symmetry of a data set. It can either be symmetrical like this, where the center of the data is kind of in the middle. It can be positively skewed. This is positively skewed, so when the hump is on the left, it's positively skewed. This one's symmetrical, positively skewed, and when the hump is on the right, it's negatively skewed. So pretty simple. The next part of the lesson, I had done a picture on my phone, but it didn't upload Dropbox for some reason. So let me try to just take a picture right here on this next page. see, insert, take picture. There we go. Goodness for technology. Okay. This is on the next page, and it talks about this grouped discrete data. So what they do is they have an example. It's on the bottom of page 204. It talks about a local hardware store. It's at the very bottom of page 204. Has a bunch of numbers listed. And it says a local hardware store is studying the number of people visiting the store at lunchtime. They track this over 30 days. So obviously if you look at the numbers, I don't have those here, but they are 37, 30. So the first day they had 37 people over lunch. The second day they had 30 people over lunch. Then they had 17 people over lunch and 13 and so on and so forth. So anyway, sometimes it's really hard to keep track of these data because it's a bunch of individual numbers that don't have, that list is kind of tedious the way it is. If you look at it, it's just annoying to look at because it's just almost all of the numbers are different. So that's where this group data comes into play. So what they did was they did ranges. So rather than listing the numbers individually, they did ranges. So they did like 10 to 19. So if you had between 10 and 19 people, you would put the tallies here. And if you have between 20 and 29 people, you would put the tallies. Keep trying this again. It keeps disconnecting. I don't know why it's having such trouble. Anyway, if you have between 30 and 39 people, you put tallies here and so on and so forth. So starting with this list that they give us at the bottom of page 204, looking at that list, first number is 37. So you would put a tally right in this range. You put a tally right here. And then the next number is 30. So that is still in this range. So you put another tally right here. And the next number is 17. That's in this range. You put a tally here. Next number is 13. Again, this range. So you put that here. And so on and so forth. And you keep doing that for all the numbers. I usually cross the numbers off as I go because it makes it easier to keep track of what I've already done and what I still need to do. And that's how you do grouped discrete data. It's grouped. So rather than doing a bunch of individual numbers, that's really tedious to look at. That doesn't mean anything to me, that list of numbers. This is a lot more meaningful because you can see the groups, okay, between 10 and basically 20 people, between 20 and 30 and 30 and 40 and 40 and 49 and so on and so forth. You can kind of see the ranges in this. So this is a lot more meaningful than that list of data at the page 204, at the bottom of page 204. So that's what grouped discrete data is for. Helps to give a meaning to it. You can visually see what's going on with this. And you can also see the center of the spread is kind of sort of positively skewed. Because it's kind of symmetrical. It's almost because the bulk of the people are kind of sort of in the middle. And not at the end. See, these ends are kind of not as many people. So it's almost symmetrical, but it looks like it's going to be positively skewed because you have the higher numbers are slightly to the top right here. So it looks like if you were to do bar graphs for this, it looks like it would be positively skewed. So anyway, so this kind of gives you a better idea of what's going on with the data rather than just listing a bunch of random numbers that don't mean anything to anybody. So anyway, that's pretty much the lesson. It also talks about outliers. Outliers are, for example, let's say in a class at Briss, most of the people get A's and B's. So most of the people have like grades in the 80s or 90s. And let's say you have somebody that has a grade that's like 5%. That's like unheard of at Briss. So that would be an outlier because it's just way kind of out there. Usually we throw outliers out because they throw the data off. So like now they wouldn't tell people, oh, we have some. She wouldn't even average that in if she were like to tell prospective parents about the average grades or whatever. She wouldn't even include that probably because it's obviously an outlier. There's some kind of issue going on with that student. And so that's what an outlier is. It's something that's kind of outside the norm for that data. And usually you would typically exclude that when you're doing different types of statistical analysis type things, because it kind of would just throw off your average, so to speak. So anyway, you have quite a long exercise, so I'll let you start working on that. You probably don't have to do the whole thing. I guess it's only 7. It looks long, which is a bunch of things. So try to do as many as you can. The more you do, the better off you'll be for the rest of the chapter, and also for when it comes time for the test. So try to get done as much as you can, and I will see you hopefully. I don't know if y'all are coming Thursday and Friday after Mardi Gras break, but if you are there, I will be there, and I will see you. So anyway, have a fantastic Mardi Gras break, and if you need to see me for anything, I will be at school after 2 o'clock, so around 2 o'clock I'll be getting back to school. So if you need anything or you need to finish a test, make sure you come see me before. I'll probably stay till, if you need to stay after school, I can stay after school if you need to work on something. So just let me know before I leave. So as long as you catch me before 4, we're good, okay? All right, well, I will hopefully see you tomorrow. If not, I will see you after Mardi Gras break. Bye.